All right, what's going on, everyone? Now, today's lesson is going to be fun. It's a little abstract, and it's something completely new. So it should be pretty cool, and we'll talk about it again tomorrow. But let's say we're presented with a problem like this. We have x squared plus 1 equals 0. All right, now, what section 5.4 is titled is complex numbers. All right, we're going to be dealing again with something new today. Now, we have x squared minus 1 equals 0. We know how to solve with x squared, so let's go ahead and go through our necessary steps. So x squared is negative 1. Square root both sides. We're not allowed to take the square root of a negative. Now, for years, your math teachers, sorry, but they all been lying to you. All right? We can take the square root of a negative number. Now, the square root of negative 1 is equal to I. Now, I stands for an imaginary number. Yes, that's why this is called complex. It's very complex. There is a such thing as imaginary numbers, and that's what we use when we take the square root of a negative. Now, there's a lot of things that go along with this I value, but this is where we need to start. The square root of negative 1 is equal to I. And we'll learn how to deal with it and give some further explanations as we go along here. So let's say you're presented with a problem such as this. X squared plus 9 equals 0. All right, so we subtract 9 from each side and we get x squared equals the square root of negative 9. All right, now we square root both sides and we're left with x equals plus or minus the square root of negative 9. Now, you got to think about this very carefully. Okay, when you take this out, we have this plus or minus the square root of negative 1 times the square root of 9. So you have to split it up. So the general sense of that, the general terms of that would be square root of a times the square root of b equals the square root of ab. And normally we multiply, but this time we want to separate them so that we can get the solution of plus or minus, oh, I'm getting ahead of myself, plus or minus 3i. All right, so that's our final solution. X is equal to plus or minus 3i. All right, let's try another one. A little more complicated. So we have number 2. 3x squared plus 10 equals negative 26. So subtract 10 from both sides. 3x squared equals negative 36. Divide by 3. X squared is negative 12. Square root both sides. Whenever we square root both sides, don't forget your plus or minus. So x equals plus or minus the square root of negative 12. And I forgot to write my negative in there. Negative 12. Now, we need to break down the square root of 12 to get 4 and 3, 2 and 2. So 12 is 2 root 3. And remember, we have the square root of 1 times square root of negative 1 times the square root of 12. All right, which leaves me with x equals plus or minus 2i times the square root of 3. All right, so that's how we work with I. That's what I is. Now for the complex numbers piece. All right, so complex numbers. We have a standard form for complex numbers, just like we have standard form for everything else. So we have a plus bi. Yeah. All right, now our a is considered our real part, and our b times I is considered our imaginary parts. Now, I know it's hard to wrap your head around that we're dealing with imaginary numbers and you can really see it, but they're there. So, one way I like to think about this, and we're going to multiply them. All right, think about it this way. If we have the square root of 7 times the square root of 7, what do I get? Square root of 49, which is just 7. So notice the number under the square root comes out. Let's say we had the square root of 137 times the square root of 137. I get 137. What if I had the square root of 14 times square root of 14. I get 14. I get a little redundant, I know. So now think about this. The square root of negative 1 times the square root of negative 1 equals the square root of negative 1 squared, right? This would be up here, square root of 14 squared. So in a sense, the square root undoes the square. So I'm left with negative 1. Now, just negative 1, sorry. I showed you all these to highlight that. 137, 137, 137. 14, 14, 14. Negative 1, negative 1, negative 1. All right, you can't think of it in a sense of, well, negative times a negative is a positive. No, that doesn't work here. All right, it's the square root of the square root. You get the same number under the square root. So what conclusion can we draw from this is that I squared is equal to negative 1. All right, and that is a very, 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 very important piece here. Square root of negative 1 times the square root of negative 1 is I times I, which is I squared, which equals negative 1. All right, so that's how we handle that. So whenever you do something and you multiply your complex numbers and you're left with an I squared, you can go ahead and substitute a negative 1 there. All right, so it's a way that we can simplify and work with negative square roots. So multiplying complex numbers. What example are we on? 3, 4? Let's go check. That was 1 and 2. We are on example 3. So let's go 5i times the quantity negative 2 plus I. All right, now all this is here is the distributive property. We're going to take it to both. 5i times negative 2 is negative 10i. 5i times I is plus 5i squared. So negative 10i stays the same. Plus 5, well, I squared we know is negative 1. So I got negative 10i minus 5. Now, you have to be in standard form when you're writing this. So our real part comes first, and our imaginary part comes second. And we always write our solution in that order. All right, number 4. Let's go 7 minus 4i times negative 1 plus 2i. All right, so this is set up to be a binomial times a binomial, which most of you call FOIL when you multiply this out. So 7 times negative 1 is negative 7. 7 times 2i is plus 14i. Negative 4i times negative 1 is positive 4i. Negative 4i times 2i is minus 8i squared. So I have negative 7, 14i plus 4i is 18i. Negative 8 times negative 1 would be plus 8. So I get 1 plus 18i. Alright, so that's multiplying complex numbers. Now, I need to introduce one more concept to you guys, and that's called the conjugate. So let's say we're starting with this. Now, when you conjugate verbs in English, what does that mean? Well, I don't really know what it means either. Maybe you guys can teach me tomorrow. But in math, when you conjugate something, you take this, so 4 plus 5i, so the conjugate would be 4 minus 5i. Alright, so all we did was kind of change the sign, but what about this one? 3 minus 8i. So the conjugate of 3 minus 8i would be 3 plus 8i. Right, and then let's try negative 5 plus 6i. The conjugate here would be negative 5. This first piece stays the same. The middle sign changes and the back piece stays the same. Alright, so if there's a negative out in front, that needs to stay the same. Alright, so that's what the conjugate is. Now, what in the world's the purpose of it? Right? Let's say I gave you a problem like this. 5 plus 3i all over 1 minus 2i. Now, keep in mind, I represents the square root of negative 1. Are you allowed to have a negative 1 in the basement? A square root in the basement? Alright, we are not allowed to have a square root in the denominator. So how do we get rid of it? We need to multiply the entire fraction by the denominator of the conjugate. Kind of like rationalizing the denominator, but this time we're taking the conjugate. So I'm going to multiply by 1 plus 2i over 1 plus 2i. Alright, again, I can do that because if you divide those two, you get 1. And then you need to FOIL out the top and the bottom. So 5 and 1, give me 5. 5 and 2i is 10i. 3i and 1 is 3i. 3i and 2 is 6i squared. Now that's what it is, but let's take a look at what happens with the bottom. So I have 1 times 1 is 1. 1 times 2i is plus 2i. 1 times negative 2i is minus 2i. Negative 2i times positive 2i is negative 4i squared. So if we simplify the top, I get 5 plus 13i minus 6, because that's a negative 1. So 6 times negative 1, all over 1 plus 2i minus 2i. Those middle terms are always going to cancel whenever you multiply by the conjugate. Alright, that's the point. That's conjugating. That's what happened there. Negative 4i times negative 1 gives me plus 4. And from there I get negative 1 plus 13i all over 5. And I no longer have a square root in the basement. And that's that. Alright, we'll see you tomorrow.